Welcome everyone. Thank you for joining us today for the webinar. My name is Nikhat Ikram and I work at Codvo's marketing division. Codvo, as you may know or may not know, is a fast-growing, pure-play product engineering company that believes in bringing ambitious ideas to life through agile methodology. And in the webinar today, we'll discuss how to make the change from the monolith to microservices as seamless as possible. We will talk about the strategies, ideal practices, and much more. So, without further ado, let me introduce the speakers for today. First, meet Shashank, currently working as Engineering Manager Third, with a strong background in managing engineering teams and projects for more than 7 years, delivering web services, cloud-based solutions, and security-based solutions using Python and related frameworks. Presently working in a highly iterative agile environment to release major features and own the software delivery from concept to code and to production, using basic practices for quality software development, DevOps, microservices, REST APIs, and SaaS. Next is Devang. Currently working as a senior backend lead in Codebo.ai, he has overall 7 years of experience in the IT industry. He has contributed to the development of scalable SaaS products in a variety of industries, including EdTech, FMCG, FinTech, community applications, etc. He has a lot of expertise in developing scalable architecture designs using microservices on the AWS cloud platform. He has developed large-scale applications using Flask and Python 2.7. He has helped products make the shift from monolithic to microservices architecture. And next we have Asif, currently working as an engineering manager in Codebo.ai. In total, Asif has 15 years of experience working in the IT sector. He has expertise in building APIs, managing databases, cloud infrastructure, IoT, Docker, Kubernetes, Jenkins, Ansible, etc., as well as end-to-end tech connectivity in terms of desktop and mobile applications with a focus on efficiency. He is also skilled in PHP, Python, Java, React.js, Node.js, and building custom cloud-based applications from scratch. Next, Khushbu, I would like you to take it further. Thank you.
Yeah, welcome everyone. So guys, if you have any sort of questions or queries, kindly ask them in the chat box so that we can, address them at the conclusion. Additionally, we will be announcing 2 lucky winners and we have something special for you guys. So the criteria for it is that you have to post your experience about this webinar on LinkedIn and tag Codebo.ai. So yes, so you guys make sure to tag Codebo so that we can see your post. You can submit your entries by today end of the day. You can be as creative as possible. You may add a simple caption sharing your webinar experience at Codebo, or add screenshot of the webinar or anything creative. You can be as creative as possible. We will select 2 winners from all the entries we will receive, and those winners will get Zomato vouchers of 1,000 rupees each. So yes, we will announce the winners by Thursday over the email. So looking forward to your participation. If you have any questions, you can just, enter that in the chat box. We will address them. Shashank, we can start.
All right. First of all, good morning to all present. So today we'll be seeing a journey of migration from monolith to microservices. And to begin with, let's go through a quote by Alberto. Building a software is a learning process, and working code is a side effect of it. Essentially, like this is similar by saying that the main value in software is not the code produced, but the knowledge accumulated by the people who produced it. And this is ever evolving. It's not that you have a certain set of knowledge and that is sufficient for you to go ahead and go ahead for a lifetime. Architectures evolve, technologies evolve, stacks evolve. So the learning process should not stop. All right. So what is a monolith? What is a microservice? You'll find like hundreds of definitions for this. Some quotes that I picked from the web for this is like, monolith is an entire application that runs in a single process. We can also say that monolith is any system that's not built or independent running microservices. A microservice is a very small single purpose service that does one thing and one thing only. Okay. And also directs to a business unit or a business case. Microservices are the idea of having a bunch of smaller programs talk to each other to implement a larger product. Moreover, these are just architectural patterns. And the kind of difference between a monolith and a microservice, we can see in this. I think this is a diagram by Martin Fowler. It's a very old diagram. Back in, I think, 2014, 15, I got to see this diagram. But if you see on the left-hand side of your screen, a monolith application puts all its functionality into a single process, okay, and scales by replicating the monolith to multiple servers. Whereas a microservice architecture puts each element of functionality into a separate service and scales by distributing these services across servers, replicating as needed. Okay, so this is a very basic level of difference. We will, I think this still not make it clear, but that also gets us thinking like, what is a monolith, what microservice, what's the difference, what to do, what to choose, when to migrate. A lot of things might be running. So let's talk first about what the heck is monolith. And monolith is at the present day, one of the most controversial tech stack that we are seeing, especially with SaaS-based startups, SaaS-based companies, which are now a gigantic monolith-based architecture. They are struggling with code. They are struggling with deployments. They are struggling with change. They are struggling to scale. They are struggling with their big teams. The team velocity is down. So, and I think you always get warned by your CTO or your director that, okay, this is a monolith application, be very careful with it, because even a single line can stop the entire application down. And if you are a SaaS-based business, that means your business is down. Okay. So let's try to understand what kind of monoliths we have. So the very basic monolith is a single process monolith, where all code is packaged into a single process and all data stored in a single database. Okay. If you have developed any kind of backend application, let's take an example of Django. If you have a single app there and a single database attached to it, it just perfectly replicates a single process monolith. For small POCs, this do work, because you don't need multiple things. You don't need multiple modules. A single module, a single process works. Now comes in the modular monolith, where you have multiple applications within your monolith serving the same database. So basically the code is broken into modules. Each module is packaged together into a single process. This solution is very highly underrated. For people who are starting to build a service or starting to build software, the term microservice is very catchy and very in trend nowadays. So people forget about, okay, can we do it in a modular monolith way? Why to go for microservice? they don't think about this. They just follow, okay, microservice trending in tech and everything's happening around it. So let's do microservice. Why to waste our time in monolith? We'll see why to waste our time in monolith. Now, this is a very dangerous scenario. And I think a lot of clients I've worked with are or were in this scenario of distributed monolith. And this is one structure which I never ever recommend any company or any software to be in, because monolith trying to be a microservice but still a monolith, and it's not actually a proper monolith also, like how we saw in the last slide, a modular monolith. This is something else. You have 3 containers using same database. All 3 of them are dependent on each other, dependent on database. The coupling is very tight. Okay, they have large scope deployments, 10 services going at one time. Okay, any service goes down, entire system goes down. Release coordination is required. Okay, QA is communicating with dev is communicating with 10 other teams. Those teams are communicating with DevOps. You have 5 hours release calls. You are like, the cost of change is very high. Okay, even if you want to make a single line of change, let's say if you talk in context of e-commerce, let's say you want to make a single line of change on your order management system, you have to test not just order management system, but you have to test invoicing, you have to test notifications, you have to test wherever that order management system is getting utilized or is being used by, okay, or is using, because it's such tightly coupled that its impact would be on the entire system. So the cost of change is really high. And as I mentioned, watch out, there's a release train coming. These kind of deployments, if you see, you will be seeing like 5-10 services getting deployed at the same time. They're thinking that they are microservice, but they are not microservice. They are a monolith, and they are a very bad monolith. So a distributed monolith we can put in short when life isn't already complicated enough for you. Then you go ahead and try to think, okay, how to complicate my life? You go ahead and build a distributed monolith. Somewhat like this. There is a monolith, there is microservice, and you try to put monolith's head on microservice and call it a microservice. Okay, this is somewhat microservice that we have. So, but what exactly is microservice? Is it a mini monolith? Okay, that can be a good question. That is microservice a mini monolith? So let's discuss about it. I think you can put down a microservice in a few pointers. I might have missed few, but mainly it is this. Okay, highly maintainable and testable, loosely coupled. Okay, if you are seeing this architecture, you can test just this specific microservice. It is not dependent that if you have to make a release on this, you have to update all of these, and we'll talk about it. What is the advantage that it makes easily testable and loosely coupled? Independently deployable, organized around business capability. This is very important. I think we'll be covering this around DDD also, domain-driven design. But organized around business capabilities is that, let's say, back to the e-commerce example, let's say I have an invoicing to make, okay, in my business. It's a business capability that my business can create invoices. So a microservice can just serve invoicing. It doesn't have to serve all the XYZ things that monolith architecture has. So a separate microservice can be for invoicing. A separate microservice can be for just managing the orders. A separate can be just to manage the notifications that we are sending, be it email, be it SMS, be it push notification. All the notifications can be managed by a single microservice. So organized around business capabilities and owned by small teams. When you are a team of, let's say, 5 developers, okay, then you will not have any problem in working with Monolith. But when you are a team of 50, you can imagine, let's say there are 5 teams of 10 developers working on different parallelly working, because there's always a urge to, how do you capitalize on 50 developers? You need to work parallelly, but the team velocity slows down because, let's say, team A, B, C, D, E, but team A has to make a deployment. So B, C, D, E is waiting for team A to deploy, then they'll rebase, then they'll add their change, the regression will happen. So you're trying to understand how the team velocity is slowing. There are a few myths around this. I think microservices are synonymous with containers. No, this is very wrong assumption. And I have heard this many times before that, okay, we are trying to build a container-based system that actually is a microservice system, that people try to relate it. But in modern architecture with adoption of DevOps, yes, DevOps adoption is also for Monolith. It's not just for microservice that DevOps works on just microservice, it works for Monolith. You are creating containers for monolith-based architecture also, you are creating containers for microservice-based architecture also. It's just a modern architecture, good and best practice out there that we use containers. And second is, I think it's widely, like I have heard few times very recently also, that it is much easier to build a monolith than a microservice application. You need less technical and architectural skill. This is very wrong myth. Leaving aside the infrastructural skills that you might need to orchestrate or operationalize microservice, but that's also a very quick learning. Rest, all the technical and architectural skills required is similar to how you will be building monolith, okay, and at the same complexity level, because managing monoliths is equally or more complex than managing microservice, and more costly. Okay, people think microservice is cheap. They just think about infrastructure. Okay, we have just a single service, it's cheaper. But what about your time? The time that your team is waiting for team A to deploy and then your deployment to go, that time you're not counting. Okay, that will be more than your infrastructure changes. All right. So these are the few things. Now, as I mentioned, each has its advantage. I'm not saying that just go for microservice. My first preference is monolith. And I'll talk you why I am saying this. Number one is infrastructure simplicity, up and running faster. Code simplicity, okay? Don't need to worry about latency, graceful failure. Like when you are writing code for monolith, it's really simple. And this code simplicity is one of the single biggest reason why companies are not migrating from monolith to microservice. Because when they do effort estimation, they get to know, okay, if I do an incremental change on my existing monolith, it's taking me 2 days. Whereas if I go ahead, build out a service in a form of microservice, the incremental change might be 10 days, because we are trying to separate the DB, we're trying to migrate, we're trying to do the transition. There'll be additional work, but they don't understand the kind of information hiding that is happening there. So next is that architecture and organization simplicity. There's no hard boundaries, shared tech stack, because in the monolith, we have the entire stack is similar. Everyone is using the same Python version or same framework version, same language version, database is same. So tech stack is shared, so there's no hard boundaries around it. Now, when we talk about advantages of microservice, there is system ownership, right? The decoupled tech stack and API contracts come into play, because all the microservices need to communicate with each other, and that happens through API contracts. And these API contracts are, you can say, a kind of a transparent document between microservices for communication. All right. And each microservice has to follow the contract in order to work. Smaller components, easier to read code. As I mentioned, if you have smaller, the code complexity reduces. Code simplicity remains similar. Okay, if you are writing code for a smaller component, simplicity would remain similar. But in monolith, the complexity of code is very high, because the monoliths usually tend to become such big mammoth kind of system that you need a person sitting right next to you explaining you each function, and you might still miss 2-3 points. Then scaling separately, add more to service that are bottlenecks. Finding bottlenecks is very, very difficult in monolith, because let's say there is XYZ. Okay, in monolith, service X is serving service Z is serving service Y, service Y is serving service X. Okay, and you don't find a bottleneck. You first start with service X, identify, okay, it might be service Y, then it might be service Z. It might be too late till the time you reach service Z. But if you are following a microservice based pattern, you'll instantly get to know, okay, service Z is the one which is taking most of the time and which is the bottleneck that we need to scale. Okay. Now, building microservice first versus monolith first. After hearing all these advantages of microservices, you might be thinking, okay, I'm building an application. Let's say I'm building an application from the start. Why not should I just directly go out and build microservice? Because it's pain. You don't know what you're trying to build. Okay, and you're treating microservice as a default option, which should not be that. Okay, all the successes that we have seen in the past, which are successful microservice architecture at the moment, are services which transitioned from monolith to microservice. If you want to go and build, I'm not saying that you don't go out and build with microservice first architecture. You go out, build that, but you should have very, very solid reasons for that. And we'll be talking about what solid reasons you should have before you decide, okay, let's do microservice first. It is really painful to be making short, because real pain doesn't start in development. Real pain starts when things go production, especially when you try to do microservice first based architecture. Okay, as you are seeing, this is a great diagram by Martin Fowler, and I think back in 2014-15, this was laid out. Going directly to microservice architecture is risky, very risky, because you get to know about things failing in production. Okay, and you'll face dragons on the way. But a monolith allows you to explore both the complexity of a system and its component boundaries. If you're doing a POC, you're starting out, start out with monolith. And I have very core reasons behind it. I will discuss about it. As complexity rises, start breaking out some microservices. On the incremental change, okay, let's say you built a basic functionality around a monolith. On the incremental change, as complexity is rising, you break out some services. And that is how you continue breaking out as your knowledge of boundaries and services and management increases. Okay, as your team increase, as your technology increase, as your complexity increase, as your scaling concerns increase, you start breaking out services, and that is how you end up into a microservice based architecture. Don't ever think of like, okay, I have to build 10 things, all right? And that is in plan, but you have a team of 3 developers, but you start building out 10 different microservices. Okay, that's not you. Team of 3 developers will not be able to manage 10 microservices separately. Okay, then you might have to scrap all of them and come back, start with one. Then on incremental change, when one is successful, you start building the second, because initially you start with the monolith, then as complexity rises or as your business requirement rises, you start breaking out some microservices. Microservices shouldn't be the default option. If you think a service architecture could help, try it once with one of the modules from a very simple monolithic topology and let it evolve from there, as we saw in the last slide. And when you're building monolith and you're trying to migrate and do an incremental change, for God's sake, avoid distributed monolith. Okay. And how to do that? Create a deployment mechanism. Whenever you try to break it out, create a deployment mechanism and strive for independent deployment for the service that you build. That service's deployment should not be dependent on your monolith. Okay, if that service is deployed, monolith should also be deployed so that the change can be reflected. Okay, so you have to build in such a way where a deployment mechanism can be created and independent deployment can be strived. It might not be possible in first iteration, but try to reach there as soon as possible with the deployment mechanism that you come out with. Then look for patterns and deciding how to deal with them. Information hiding, people don't know in the industry what it does mean. How a commit level information helps you decide if you want to break out into a microservice or not. Information hiding leads to distributed monolith. Information hiding leads to a tightly coupled system. Okay. In one commit, you've written such a code which depends, let's say you've written a module Y, which depends on module A, B, C, D, E. Okay. And it's 5 modules it is dependent on. The module Y, when you're thinking to separate the module Y, you will be in such a complex situation that how can these services be communicated with module Y? And it's already late. You had the choice to separate out the module Y's, but right now it is tangled up with module A, module B, module C, module D, module E, and it is getting used, or it is using all these services internally, that when I pull it out and try to find the latency that it would bring in to serve all of this would be very high. Okay, so information hiding is people don't know really what information hiding in this entire context is. Our industry tends to focus on tech instead of the outcome, and this is very, very true. Tech sounds, I'm not talking about like at the business level, but in the tech industry, people are really tends to focus on tech instead of the outcome. One should use microservices as a means to obtain result outcome rather than for the sake of using a new technology. It's just an architectural pattern. It's just a choice that you have to make, but it should serve some outcome. And what are the key signals to know that, okay, it's time to split? We are done with our monolith. We have built it out, built our POC, but now it's time to split. Now it's time to split, break it out. And there are key signals to it. Number one is that lack of maintainability, and it's very, very important. No one fully understands the complex code base and its relationships. It's slow and risky to build on top of it. And we might have joined any company with a monolith architecture. You can understand the horror and the pain a developer goes through in order to just understand the complex code base. It might take them a month, 2 months, still they might not be able to understand the relationship. Okay. Sometimes it takes years to understand the relationships happening around. Okay. And it's very slow and risky to build on top of it. Concerns with scaling and fault tolerance. When portions of functionality errors out, the entire system freezes. Okay. And part of monolith is receiving large volume. Let's say in an e-commerce system, we have user profile. Okay. And customers are, let's say, suddenly the customers are utilizing user profile a lot. And there is a very large volume daily, 3 million, 5 million. On other side of the application, you don't have this kind of volume. But let's say we have a module for deals. Okay, everyone is constantly checking for deals. So a part of monolith is receiving larger volume. Okay, but you cannot directly pull it out, or you cannot scale that part. You have to scale the entire monolith to scale that part. And if the monolith holds state, okay, and this happens with database migration failing, happens with deployments, and happens with when system errors out. So monolith can hold state and you cannot do anything about it. You have to spin up your backup. You have to like just open a war room to handle this kind of situation. Organizational growth is very important. I think an architecture resembles the kind of organization and team structure you have at your organization. Okay, a monolith kind of architecture resembles the kind of structure that you have. Same way, and microservice architecture resembles the kind of organizational distribution that you have in your organization in terms of work, how the work is happening. And as engineering team is expanding and new teams are spinning up, organizational growth tends to slow down team's velocity when we are working with monolith. Okay, as I mentioned earlier, 5 teams working on parallelly, team B, C, D, E waiting for team A to deploy. Then they will rebase, they will retest, regression will happen, then team B will do, then team A, C, D, E will rebase. So it's a lot painful and the team velocity slows down very much. Now, okay, so as I discussed earlier, I think there should be solid reasons to introduce microservices. And the top 3 reasons, there might be many reasons, okay? The top 3 reasons should be, number 1 is zero downtime, independent deployability, okay? And this is not for everyone. I'm frankly saying, if you are running, let's say a website which has 100 visitors a day, you don't need it, okay? If your website is a byproduct of what your business is, and it's not the entire business, you should not strive for it, okay? Who should strive for it? For a case study, you can take SaaS-based business, where you can't afford downtime. If your website or your application is down, your business is down, okay? You don't have any other source of income. So it's a SaaS-based business that you can't afford downtime. Isolation of data and processing around the data. This is, I think this particular point is very critical for specific industries where data is very crucial, and where the data lives, who has access to that data, okay, and who can utilize the data is very, very important. And I think biggest example is the healthcare industry, like how to know where customer data is and how to implement like right to be forgotten. Enable a higher degree of organizational autonomy. Distribute responsibilities into teams to reduce the amount of coordination with the rest of organization and reduce the amount of coordination those teams need with other part of the organization. Okay, so this will help definitely in increasing the team velocity and the kind of the parallel work that we were discussing, that we very much need as the team scales. We need 5 teams to deliver simultaneously or deliver together. It's not that team A is delivering, team B, C, D, E is waiting. So we don't need a release train. Okay, get rid of release train and always strive for independent deployability. No one starts with microservices past a certain scale. Everyone ends up with microservices, and this is the truth. Okay, this is the truth, and I think most of the startups and companies, be it eBay, Amazon, GitHub, Uber, were a very big, gigantic monolith, and now they are a very safe kind of a microservice-based architecture. And GitHub transitioned recently. They were there with a monolith based architecture for almost 12 to 14 years. Okay. And you can understand, like, I think around 2020 they migrated. You can understand how difficult it was to deal with monolith based architecture for such a long time. And yes, definitely they had the courage to migrate completely. The process might have started much earlier than 2020, but finally it was done. Now, dealing with this kind of a scenario where how do we decompose? Okay, how do we break it out? What should we do to break it out? We'll take an example of an e-commerce monolith, and it's pretty common and I think easily understandable by you guys that how an e-commerce system works. You have invoicing, order management, brand loyalty, like you get points, okay, and you have notifications that you getting sent off. Some of the common services, and there are other services also. Invoicing, order management being at the top of the architecture. But if you go down, loyalty and notifications, these are kind of services which are dependent on invoicing or order management or XYZ, many services to serve their functionality. Okay. So migrating modules for loyalty notification would be much difficult. Now, you won't appreciate the true horror and pain, suffering of microservices until you're running them in production. Okay. And I already mentioned you, like if your microservice is not running on production, okay, and you're thinking that local development is done, so the microservices are created, it's not. Okay. The true horror and pain starts when your microservices running in production. If you do a big bang rewrite, the only thing you are certain of is a big bang. And essentially migrating from monolith to microservice is a big bang rewrite. Okay. So the migration pattern we must allow, must allow for incremental change. Okay. We understand, like as I mentioned earlier, you should always go for a monolith first architecture. And as you have an incremental change, when your project is live, don't make assumptions that, okay, you will have 3 million, 5 million users and you need microservice at very start, because you don't have, right? That's just an assumption. But as you have a project live, the migration pattern that we must allow for is incremental change. Okay, pattern that allows for our architecture to evolve while still delivering features. And one such pattern is a strangler fig pattern. Essentially, if you're seeing there's a tree, okay, around that tree there's another tree growing on that tree, okay, and using the assets of the inner tree. Okay, so first of all, what we need to do is that asset capture. Identify the functionality to move to a new service. Okay, and this is very, very important and might take some time to truly identify what to move first. Depends on your business criticality and the dependence on that service. You're trying to do a safeguard. Okay, so let's say in your room there are hundreds of items. If you have to run away with one item, what will you pick up and run away? Maybe your wallet or mobile phone, right? Because you need that for communication and whatever you want to buy or whatever you want to, because all the exchanges are with currency note. Okay, so or with card you will be making payments. These might be the two essential things that you just run away with. Okay, you might not run away with your pillow. Okay, that, okay, if I have this pillow I'll be able to sustain. No, you need to buy food, you need to eat something, you need to communicate with other people to help you out on things. Okay, so you might be taking your phone and let's say then you get a chance to come back in your room and pick again one thing, okay, then you might pick something. And just think of like identify the functionality as per criticality you want to move to a new service. Redirect calls, intercept calls to hold functionality and redirect to new service. That we'll be discussing and seeing how that happens. So very first thing, as I discussed earlier, is that what we have to do branch by abstraction. Okay, let's say we have to migrate notification. Okay, notification module. So what we need to do is that create an abstraction point. This interface is the abstraction point. What it is doing, all the requests that are coming in, okay, the interface is handling the request, is sending the request to the notification module. Previously, it was directly contacting the notification module. Now we created an abstraction point. Simultaneously, we need to start work on the notification service that we want to migrate and just create a service that will be calling the notification service to serve the request. Meanwhile, we have the interface which is acting as an abstraction point to the notification module. What we need to do next, once our service is ready, we need to switch over the call. Okay. Instead of the notification module, we switch it over to the service calling implementation. And then it serves the notification. That is how we've broken out a notification service outside of our monolith. And it's not over yet. Okay. When you do that on your testing, I recommend that you do a parallel run. Okay. To know more about your objective is getting, or your outcome is getting served or not, you have to definitely compare it with the existing module as compared to the notification service. And I think the QAs will also be very happy if you do something like that, where the comparison is with the old module and how the new service is running. And once you are done with it, just clean up. Just remove this notification, remove this interface. You don't need the interface also now. Directly send invoicing to service calling implementation, orders to service calling implementation, and you should be done. Handling data is, I think, the most complex part of migration. A lot of the complexity of breaking rules system lies in the data. After extracting the microservices, you need to understand what type of old database the system uses. Okay. So as you saw last slide, we have extracted service. Now we need to understand what to do with data. Okay. How do we get the data there? All right. So now I think with handling data, I would like to pass on the webinar to Divyang. Divyang, please take over.
Thanks, Shashank. That was quite informative. Good morning, folks. I'll be taking the next part of handling the data. The major concerning point in every services that we deal with is what's next, because data being our crux. And right now in the current scenario, data being a very, very important aspect of any software company, organization, data is a key to everything as of now. Right. So let's dig deeper into how can we split the data into or handle all those specific cases where we are dealing with distributed database systems and having a monolith database intact and different patterns in handling the data to move from one source to another source. Okay, so first, restructuring an entire database at once during a microservice migration is a bit like trying to drive a car and change its tire at the same time. Moreover, it's like you can see it's a self destruction if you have to do of any specific application, right? And I would say to start. Moreover, with databases, it's not a simple endeavor. If you are starting with these migrations, because it holds a lot of understanding with your underlying data. Let's look into one of the aspects of CAP theorem. I know this is moreover like a theoretical approach, but let's dig deeper into more of a practical analogy that we could bring out, right? Let's see what's consistency mean, right? In a very simple term, to explain the consistency is when I read from it, I will see what the most recently written is. So let's say if I have a database which has a highly consistency in it, just for an example, let's say MariaDB, SQL Server, Oracle, any of that fact, right? We are not considering its, I would say, its tolerance or partition tolerance or its network tolerance, how it is. We just need to make sure that it's consistent. What we write, the same that we read, right? Next comes is the availability part, which is nothing but when I try to read, I can write. When I try to read, I can read. That becomes more like an availability. See, there are few software applications that I have dealt with where some of the cases where we are primarily have a focus on consistency and availability, but we are not worried about partition, right? Just for the fact, let's say Google or any specific engine where when they are dealing with, they are mostly interested in all the three aspects, right? There would be certain applications where consistency becomes a very important key to it, right? Where they need to see specific data, what exactly is there need to be seen. Next, the P point stands for the partition tolerance. Like even when we talk in the node system, there might be a cases where the system isn't up and we can still talk to it, right? Let's say we are using in-memory Redis mechanism, we are using some cache, which can be abstracted layer above any underlying databases, where we can easily do, let's say one of the system is down, we can get the readability immediately from Redis. And our scenario is that we are compliant to all the three CAP theorem pillars like consistency, availability, and partition. Let's move next. Yep. So now let's come up with the existing overhead that we have in our current scenarios. With most of the application around, I would say 40 to 50% of the software companies are dealing with this mess, that how to transfer the data or transmit the data or migrate the data from a monolith database architecture to a microservices based architecture, right? Because it's very, very tough. I would say, I'm telling you from my ground experience that it's not an easy job to move the data from here, because you cannot do it in production. You have to have a backup pipeline where you do a constant database migrations from one source to another, right? What options do we have? Do you mean that we access the data directly? Right? Don't you think that if we expose our database of direct accessibility, it gives us a security vulnerability if we are not into within, I would say, a VPC, or we have not constructed in an open or a physical database servers, right? Proposing that we are in a cloud-based domain architecture deployment, right? So let's say what exactly directly accessing data, and the comes with two aspects. One is coupling and another thing is information hiding. Let's say now I have an invoicing service, right? Invoicing service is basically coming up with a dependency internally with an order detail service. Like when I get the orders, then only I can build an invoicing service. So you can see how a monolith database and its services are tightly coupled with one another, right? One of the most disadvantages that I have seen with this specific architecture is there is no single owner of a database, right? It can be X service who can control the database. There can be Y service that can be controlling the database, right? So I would say there are many issues regarding the data synchronization. If I would have to say specifically to this, where how can I do my logical or a physical decomposition of the data? What will be the transactional integrity? What will be the impact of the joins? What will be the latency? So these are major issues that we have come across, and information hiding becomes another key thing where what kind of data that is changing. Let's say an order service which was highly controlling a specific order table changes the schema or changes any specific table characteristics. What happens to invoicing? Is invoicing updated? That is specific thing happening or not? So if this is the current scenario, let's jump into the next to see how to solve this problem in an incremental manner, right? To expose the data in monolith. So let's try to, because it's not like Rome was not built in a day, so you cannot basically move your monolith in just a just a quick snap that your data is migrated. So what's next? Let's try to figure out the patterns that are there. As we saw, we had a shared database pattern, which is, I would say, initially for a proof of concept, it holds good. But as we gradually increase our scalability, maintainability, and enhancing the product, it becomes a great job that we have to move the data from one source to another. So let's take a very specific, very easy way to do it is try to create a database access API for that matter, right? I know it's basically pointing out to the same API, but in the future steps, we'll see how to do it. Now, when we have a DB API for invoicing service, what we have actually done in the specific, whatever the details that invoicing was requiring from the database, we have just conformed as an API, as a service, where all the specific data underlying, if any specific changes happen to the DB, we reflect it onto the DB access API rather than changing the order API, the subsequent APIs, along with invoicing service APIs, right? So let's next move over what's next to it, right? Now, if we see that we have orders as a service, we have another database access API service, which is accessing it. Moreover, now when we see in the second diagram, we have two database for that fact. Now you will be, we have one API, one database that we have built for order service. There's another API that we are building for invoice. So there might be multiple cases where we have a single service, single DB kind of architecture, right? If we are moving into that way, and it's a single tenant for the fact, right? We can move into complexities further on, but let's keep it to a single tenant application where we have one order, one DB, right? Now, can you see that one of the piece link that we have to address to is how do we move the data from monolith DB order table to a order specific database that is involved, right? There are multiple ways to do it. You can have your data migration services, you can have your streams, you can have your we can have another architecture pattern where you have a single DB and you have workers and processes and Kafka streams to just populate the data, a broker kind of thing. So now you have seen that how we have easily converted. It's not that easy as it sounds to be on the picture or in the conversation, but moreover, if we are moving from one database to another, it gives us a lot of advantages. We are having a completely isolated independent services deployed. We can have their own deployment cycles and so on. Let's look next. What do we have for this thing? Like when we move the data to the new service, right? We have seen that how the invoicing data or how the DB that we broken up and multiple services were gradually created. So we have to be very clear in what kind of data aspects or the database models that we can easily decouple, right? We cannot take the complex scenarios first and let's try using it, and because we have to set up a parallel space to execute these activities, because we cannot do at runtime production, and because we cannot hamper the current functionality of the software. If we do that for the sake of microservices just to be in the trend, I would say it will be the wrong choice. It will be like self-crashing yourself, right? Coming to the next. Steps to migrate from monolith to microservices, the main title to this webinar, right? What are the steps? Are there any 5 quick steps? With the aggregation, the industry experiences that we have collectively gathered, we tried to summarize into quick 5 steps. They were like identify logical components, flattening it, and refactoring it, right? So to moreover onto this, if we have major logical components to be a part of that, we have to be very clear what component that we need to start breaking, how easy it is decouple. Second is identify the component dependencies and the groups. There might be one component, like one table interdependent on the other. There might be one isolated single table which can be a part of a group. They are solving some, they can be a part of these tables or group, they'll be part of specific services. And most probably moving forward to that, we can moreover, it's an identification problem at the initial stages. Like once we identify and we have a ground clarity of a blueprint ready for us, then we are in a position to go, right? What's next? After we have all the blueprints ready, let's now create small APIs for our user interfaces. Moreover, like we have one by one creating, because it's easy to write a code because code is it's currently there, it's persistent. We just need to decouple it for our specific purpose and we can go ahead. Fourth point is migrate component groups to microservice, right? That's a new term, microservice. It's nothing but a major thing. It's a combination of major microservices grouped into separate projects. I can have, like, let's say I have an orders history, I have something related to customer. I can start breaking down into separate projects, and then I do their independent deployments. And but having a single repository stuff, I would have a single repository, but I can have subsequent layers to it. Okay, moving on to the next. The fifth point would be the last step to this would be migrating of our macro services to microservices. And moreover, I think the last piece would be the deployment strategies that we would be covering in our later stages, that how can we handle such large scale microservices deployment. Coming to the next. Yep. So domain driven design, right? See, to be very fact, I am being from a software background or a development background where we are keen to what is the first approach of a developer? Like many of us are, yeah, we'll code it through, right? But are we envisioning the product, right? What are we building? So what's a stage that we move on, right? From a developer to an architect, what's a journey looks like, right? I would say domain-driven design, when I was coming across this specific design methodology, it excited me more. Why? Because it looks theoretical, but when we go in the ground zero, it gives us more and more insight, a clarity, what we are going to build, right? As this specific image is depicting, right? I have a big ball of mud and I have a specific planned city, right? Just for the case I have an unplanned city, I have a planned city, it becomes so easy for us. Accessibility becomes so easy, right? Let's say if I cannot build certain solutions in a planned city, that I build offices at one specific group, I build schools at one place, I build hospitals at one place. That's not the purpose. It's moreover, I have one hospital, one specific organization, one school, and all the I would say the key components of society building in specific planned way. It becomes easy for everyone, so we don't have to stretch from one place to another. Same real-time analogies can be applied to even software designing, right? So as we see, what is a domain driven design? It's basically a top down approach that we look into, like what exactly what we want, what we are envisioning it, and what we want to deliver, right? And we are developing a software. We shouldn't be primarily focusing on a technology. Or why? Because as a developer, we see that we need to be aware, we need to build a very scalable, strong, fancy, very crisp, up to the technology, but neglecting the business point, right? So moving on to that, we have to build software that helps the business to grow. And major is not the business. It should not be the software that be defining how the business needs to be run, right? Because from the business, we are basically scaling out what we need to do. Moving on to next, what the third point is, approach should be to develop the models for the domain, right? However, we are building a database design schema, right? We don't go ahead and create tables, create the columns, create indexing, create the charts, create all the horizontal scaling before plotting out what our data looks like, what are the inter table relations we have, right? So same way, it's more over like a UML, but UML also is based on that. This, I think it's a 2-decade-old technology style, but I think it's valid till now. Moving on to the next. These are two tools that DDD gives us. One is a tactical design tool and another is a strategic design tool. We can, it becomes very easy. Tactical design tools are as a software developer perspective. Strategic design tools are for the business as well for the architects who are building it, so that it can be translated from strategic design tools to the tactical design tools. And you can be very assured that what we are building out, we have project, we have layers, after layers we have modules, we have design pattern, we have object oriented approach, we have classes, then we have objects, and finally what we have is a jar file or a zip file or an exe file, for that matter, right? And similarly, when we move on to strategic design tools, we have all the specific domain, right? Subdomain, subservice. I think we'll get into more what exactly domain means, what are subdomains, what are services, what is a ubiquitous language, what are bounded context, what's a context map, right? Let's look into next what we have is, now why should a developer learn about DDD, right? A very quick question that even I had to answer it, so I added it over here. Like, first is to improve the craft, right? We have to grow at every level that we build. We cannot stop the underlying development, but we have to improve our craft. Like, okay, this is the way we have to envision a product, right? The days are gone when Indian engineers or Indian architects were basically thinking out, okay, someone would give us the work and we'll be doing the work job. But moreover, now, since we are in the startup domain and the era that we are in, even the smallest to smallest one need to envision the product, right? And I think DDD would give us that visibility, that what we want to build. There's a good quote from Steve Jobs where he says, it's not the customer's jobs to tell what they want, right? It might not be a case where I come and tell to a specific organization, can you build a specific feature for me? We have to build a feature that is universally applicable to everyone and cater to all needs, right? Just for the fact, still Apples are producing machines, or their cell phones are still with 12 megapixel camera, right? And they are giving the best picture and the image quality because their software is strong, right? Moreover, you have the other competitors who are doing more with the hardware, but they're not coping up with the software, right? So same, it's a vice versa, hand in hand kind of a scenario. Even though architecture is highly scalable and available, it's customers who decide whether the software is a use to them or not, right? The whole discussion that we are doing, we are building a microservices, we are having top-notch caching mechanisms, we are having streams, we have everything. If it is not solving the business problem, or it's not solving a customer what he wants, it becomes a redundant software to use, and soon and later we'll be starting to getting the churning out of our customers. The fourth point is a system which does not solve a business problem. It gets irrelevant how well architecture is designed or how great is the look and feel is, right? And I have seen many products in these scenarios who have been gone, right? There was a time when Yahoo and Google were doing the same thing, right? And they were solving the same search engine purpose. Now you can see where do they stand ideally, right? Similar goes with Orkut as a social media platform, which was immediately moved into when Facebook came up, right? With a very static, a single page kind of an application, right? Let's see what's next that we have. A basic example that I could jot down with the time that I had with a domain driven, so that everyone can understand. It's basically an e-commerce domain where e-commerce be our core domain. We can have our subdomains in the form of sales, and sales can be our core domain. And moreover, warehouses, billing, shipping can be our subdomain. And based on these, right, shipping, so then I can start building my services for the fact, right? Now I know my subdomains will be a specific service, will have its own database. My billing will be a specific service, its own database. Warehouse can be a specific, and these services are interconnected and reaching out to multiple platforms. See, the main problem here, or the main issue that we have, is how do these services communicate, right? It can be over REST, it can be over HTTP, it can be over HTTP1, it can be over HTTP2, it can be over event-based streaming, it can be, I can say, it can be a gRPC protocol-based buffer streaming. So there is a pros and cons for every such transmissions, right? Next, we can have the other domains that we have here. Can be a marketing domain. So marketing have a specific idea to it, user reviews, customer care. So these are specific domains and the subdomains that we can plot it out. Moving on to the next would be what are some of the best practices a microservices architecture to do, right? It's a single responsibility principle. We should have a separate data store for your microservice. We have a proxy your microservice request to an API gateway. API gateway will be providing you extra ad hoc batteries of your rate limiting, your you can place a load balancer after API gateway to balance your loads, and so on and so forth. Then you have to ensure your API changes are backward compatible. You have to version your microservices. You need to have a dedicated infrastructure to host your individual microservice. I would say the fourth point would be we have to create a separate release train. We have to use asynchronous communication to achieve loose coupling, because we cannot do asynchronous coupling because there might be a case where one of the service goes down and the entire user experience gets bad, right? We don't want to be in that scenario. We have to make these calls independently, and these are specific ways. There are more to it in the ground reality, but these are the major ones that I could plot it down, right? I think we can move on to the next, and I will be passing on my thing to Asif, and Asif can take forward from here.
Thank you, Divyang, for that informative information that you gave us on data and DDD, and also some of the best practices on microservices. So we'll be looking at retiring a monolith, right? So as we discussed so far, it is the best approach to actually build a monolith and then go to microservices. 9 times out of 10, most people go with this approach. So what is the process, or when do you actually stop the monolith, right? So it's not a quick process, that much is certain, right? So it is a atomic step migration, or small steps. So you take small steps and you evolve your monolith to a microservice. And once you are sure that everything is working, everything is in place, that is when you retire the microservice. So this involves a few key things. Orchestration comes into picture here. That is what this funny comic talks about. So if you see, all the microservices are small and the monolith is big, which means that your services are doing something very specific, but orchestrating them, making sure they're working together, is very important. That's what this comic talks about, right? So if you look at the goal of microservice, right, architectural goal would be to increase the speed of developers modifying the overall system, right? So what we need to do is, we'll have to look at how we're going to move a particular, if you just go back to that slide. Yeah, how do you move one microservice from a monolith to a proper microservice architecture, right? So we build a service first, which is what previously Shashank had mentioned, and then you add a new path to it. Basically, you create a backend call to that microservice, and then you replace in your monolith. You will connect that call to the microservice, to the new microservice, and then you retire it. So I'll quickly summarize that. So what happens here is, you decouple the new service, you move the service to a separate microservice from your monolith. You redirect all the new consumers coming to that new service, and you retire the old code path. So that is the best approach. If we can go to the next slide now. So yeah, succeeding with microservices can happen with a few points actually, but some of the most important points here are orchestration and observability, right? So if you look at points as single responsibility principle, one and only one capability is provided by the service. So you do not club your service doing multiple things. So if one thing in your microservice goes down, all right, so the other aspects of your microservice are still intact. Okay, so your architecture is still intact, which is why you've decoupled, right? You've decoupled your services. Isolation, again, this talks about how the DB should be isolated, the data should be isolated for the for the microservice that we're dealing with. Autonomy, so microservices need to be autonomous, so users who can choose to accept or reject the promise, so that can happen. And data encapsulation, so your microservice revolves around the data that is required for that. So it doesn't need any extra data, and it doesn't need to interact with another database which another microservice is working with, and that's extremely important. It is extremely important even in terms of GDPR or PCI certifications, right? So that is why we need to make sure that we have only the data that we need and the data that we need to work with that particular microservice. And then if you look at fully autonomous microservices, that is also possible. Okay, and we'll come to that later. And then we're looking at having a debugging strategy, right? We need to have a very robust debugging strategy, and I'll be summarizing that very soon. So in the next slide, if you look at deployment, yeah. So here, one of the key things that I'll be talking about later is how we're going to have centralized logging where we can see every microservice functioning and what logs it's producing. But people still go with a train release with microservices. That is something that Shashank mentioned earlier. So what happens is all the microservices get deployed at once, and that is not a very smart move. The best way is to deploy your microservice independently. So the one that you're going to deploy or you've worked on can be deployed irrespective of other microservices being affected, right? So that is the best approach. So what happens here is your new microservice approach calls for a large separate application, let's say, and the number is likely to grow. If you look at Netflix, right, it has 700 microservices right now, and it becomes very complex to deploy all of them. So what you do is you come up with a deployment strategy, and there are about one is you can have, if you just go back, virtual machines is one, containers is the second option, functions as a service, which is nothing but lambdas, and these are the three things you can do, and the fourth thing actually is to look at having a container orchestration, container-based orchestration like AKS or Kubernetes, or it is offered by Google GKE, right? And then in AWS there is another type of orchestration offered. So all the cloud providers offer it, and functions as service again, all the cloud providers offer it. So you have lambdas, you have cloud functions, you have cloud run. So all of these are available. And then finally coming to monitoring. So this is where I was talking about centralized logging, and consistent logging is very critical in making sure that the issues are identified and troubleshooting happens as soon as the issues are coming up. So how do you look at centralized logging? This is extremely important, which is why I'm touching on this aspect in detail. So CloudWatch is the best approach to start with, and then you have other options like Fluentd, or you can look at Prometheus and Grafana, which is becoming extremely big in the industry right now, and that is also offered as a service by Amazon. So Amazon provides Prometheus installed by default, so that can be looked at as well. So yeah, that's about it. And then if you look at distributed tracing, that is another aspect, and that would require diving very deep, and it would require more time. So I would be skipping that. So if you go to the references now. Yeah, so these are some of the references that we have worked with for this webinar. So if you look at the Building with Microservices book by Sam Newman, right, that is pretty much the best a book out there for working with microservices. Martin Fowler, again, a very important book. So yeah. Right, thank you, everyone. It was really nice. So time for questions. Yeah, Shashank, over to you.
Cool. I think Khushbu, Nikat, we can take questions now.
Yeah, so I've added the questions in the slide itself. You can move through it.
Okay. Wait.
So the first question that Ekta asked, right, I would like to take that. Microservice is better than API. So these are two different things, right? Microservices is different from REST APIs. You have one monolith which is responsible for everything, and you have microservices where a small thing does whatever it's supposed to do, right? So these are two different things, and I wouldn't say one is better than the other. They both have their use cases. I would give an example here. If you look at REST APIs, you can look at a college, right? A college is a REST API, a monolith basically. You go to a college, you enroll in a course, you go there every day, and you finish your course, you get your degree, right? But if you look at a Udemy, right, a Udemy course that you do, that is a microservice. You are doing something very specific. You are learning something very specific, and you get a certification for that. So both have their use cases, both have their advantages and disadvantages. Yeah.
All right, let me share my screen.
Welcome, Ekta.
All right, I think this is already covered. What is better than Microservice better than API? I think overall about as you said is API is a byproduct of a microservice. Like if you have microservice, you want to communicate, you need APIs. All right. Any service you want to communicate with, essentially, one of the options is APIs that you can communicate. There are definitely other options as well. So I think this question was raised that when migrating from monolith to microservice, what are the best strategies for deciding effective decomposition to minimize any performance impacts resulting from switching over to distributed networks, calls for intermodule communication versus inter and intra-process systems, calls for the same in the case of the monolith. Essentially, you see, I think when you're trying to seek best strategies for deciding effective decomposition, always, I think, first of all, let's say you have a monolith, okay, you want to migrate. What you should do is that, first of all, stop doing incremental development on monolith, okay? Cut your monolith out at, okay, this is a system I cannot do any development on. All right. Inform everyone in your team that, okay, whatever development that comes in will take us some time to deliver, because we cannot do any development. The cost of change is very high. All right. And if that is already understood by the team, for all the incremental changes that you're trying to do, try to create separate service for it. First of all, one path is that, okay. Other is that, like, okay, let's say you don't have anything to add, but you have to break it out, okay. Or let's say one part of your monolith is consuming high volume. You have to break it out to service, okay, separate service. You need to, first of all, as I discussed earlier, I think very simple, create an abstraction layer around it, and try to formulate all the requests coming in, handle it at an abstraction layer, and create a kind of internal API contract. You have still not migrated, but within the utilization of the particular module, create a kind of an API contract happening between the interface, okay, and the module, and the interface handling all the requests incoming. And that is how, once you are done with it, as I discussed earlier, simultaneously start building the service, and then you switch over and do parallel run, okay. This parallel run, why I'm saying is very important, is that this will help you understand the performance impacts, okay. Definitely an additional HTTP call would be made to a service to serve a single request. Previously, it would not have been required when you're dealing with monolith, but the processing speed of monolith, of the microservice, would be much higher, much lower than what you can do by a request. Let's say a query on a monolith would be much slower than a query in microservice in terms of producing the query, giving out the result. So there is always a trade-off, okay, on accessibility versus consistency, okay, and it always depends on you want to take the money or you don't want to take the money. So, but ultimately, I think when you do the parallel run, right, parallel run is that you have the existing module, you have the separated module, and you are testing the separated microservice against the existing module. Sometimes, I am saying sometimes, let's say when you are doing the parallel run, the microservice might not work, okay. You try to do some optimization. If it is still having that delay, then it might not be the right kind of abstraction applied to the microservice. You might have to come back. It's not that you design a microservice and it's a perfect at the moment, and when you do, you might have to redo things, okay, and you have to accept it. So that I think this is asked by Kshitij. I think Kshitij, you can write down a comment if you have any follow-up to this. But Divyang, you want to add anything to this, or Asif?
Yeah, there are two key things, right, when it comes to making sure that your microservice strategy works. And that is orchestration and observability. Observability I talked about already, but I did not touch on a key point in orchestration. So what is orchestration? Orchestration means how your microservice communicates, intermodule communication. That's what this question talks about here. So how is it going to communicate? There are two very key types of approaches people are doing with microservices. One is they're either going with workflows or step functions, or they're going with pub/sub techniques, right? So pub/sub is your microservice creates it publishes a message, and there's another microservice that's listening to that message and it starts acting on it, right? So that is one approach which is being followed in the industry, and the other is step functions. So step functions is where you already know which step that microservice is in, and when the step changes inside the microservice, there's another microservice that's listening to that step function, and that's actually looking at it or subscribe to it, and then it starts working on it. So both are very similar approaches, but a little different when it comes to how they're triggered, right? One is instantaneous, the other is an event-based execution. But these, when you look at it in detail, it becomes much easier to understand how the communication happens. And when you can structure this out in the architecture, it becomes much easier when you're actually building it. So yeah. So that's so as I said, right? Communication is very important. Yeah.
All right. Does using microservices increase security as we can isolate different? Divyang, want to take this?
Yep. See, microservices, as we discussed, it's a pattern or it's an architecture that we are building out, right? Moreover, if we see, right, in terms of security, I wouldn't say that it increases security, but security of an architecture, it's a separate whole phenomenon altogether, right? Just to deal with it, right? Let's say microservices, how many that we build? Like we build how many? Let's say we have 700 microservices, right? So we have larger port access to every service individually. So don't you think I have increased my surface area to which is much more prone to attack, right? Which can be attacked from external sources, it can be from internal malware, any specific of that for that matter, right? So security comes with how are you, DevOps play a very key role in structuring your security layer, like whether you want to keep it in a virtual private network. We have a VPC layer, you have every module isolated, we have hardened all the database. So isolation is another key aspect to this, right? When we are building a microservice, as we saw, we have every independent service has an independent database altogether. But don't you think if I am lying into the same database or not same database, sorry for that, if you are in the same VPC structure, can I not access another service database through my service? If I know the architecture, it becomes really easy, right? So any specific malware which is introduced into one specific service, it can be immediately create a loophole to touch upon all the specific databases if the DB isolation is not done. So whenever we are building a microservice which is having interdependent databases or having individual database mapping, we have to make sure that we completely do an isolation of the database majorly. Why? Because the DB should be accessed by that service only. It's moreover like when I come to your house, right? Your key should be your key. It should not be publicly that anyone can take that specific key and get in, right? You can understand. And if you are staying in the same premises of, let's say, a community, it's a similar example. A community is nothing but you have similar kind of houses and you have similar basic architecture, but their bounded contexts are totally different. The way that they work are different, right? Their keys are different, right? It might not be the developer is the same, but the keys are different, right? So it's a real-time analogy that we see across. I I think with that analogy, microservices security can be explained. We can build fault tolerant systems. We can build using major security layer. We can have two-factor authentications at every specific places within the like we have Okta, we have one logins and stuff like that to intercommunicate with the services. I hope I have made the point of answering this question. Do you any of these speakers want to add anything to it, or the
No, sure.
or the question who has
as famous actor said, your key is your key, none of my key.
Yep.
Okay. So it definitely helps. It definitely helps as you encapsulate the piece of code. So it's like you put a bunch of gold in one tijori versus you put small pieces of gold in 100 tijoris. So if someone wants to break one tijori, it might take less time than breaking 100 tijoris and getting the gold out. Okay, so just think in that context.
Okay.
And we have same level of security applied.
Yeah, it's the same thing. You cannot keep eggs in all the same basket, right?
Yeah. Okay. Moving next, I think it's a big question. With the introduction of distributed tenant database, okay, of independent microservices in a fairly decoupled system, how do we tackle the challenge of data consistencies across the tenants and microservice? Divyang, you want to take this?
Yep, I can take this up. See, there are patterns in DB, right? In multi-tenant systems or a single tenant system for that fact, right? There's a master-slave kind of a combination that we have. You have a leader-follower mechanism, correct? See, there's a misconception with CAP, right? That CAP takes care of all the databases that you do, and you have a consistency, you have availability. It's not the fact that you use your databases for specifically for consistency and availability. And moreover, this question is tackling out how to handle I would say the dirty reads and dirty writes. That, let's say, if we have a very consistent database, right? For that fact, we have written down a specific data on one specific writer, and the follower needs to read it. And let's say we have two followers or the replication pattern. Okay. What exactly happened here was the data was written. It was sent to the first follower. There was one request concurrently coming from one of the user. It accessed to that specific layer and got the data. When the second user gets the same request but doesn't go to the same follower, it goes to another follower where the data was not updated, he will see a totally different data, right? But when I say in terms of consistency, right, my data was successfully written down on that specific this thing, but when he refreshes it, I basically get to read that source of data. So we have to be very sure that which parameter that we are focusing on. We cannot use an RDBMS in such specific cases if we are dealing with the real-time data, right? When we are dealing with in-memory data, when we need the data as quick as possible, let's say for the fact we are doing some scoring calculations or I would say a stock ticker, you cannot rely on RDBMS to give you data in prem or in fraction of a second. I think we need to go with different databases to tackle such challenges. And in terms of data consistencies, right, we have to be very sure what data sources that we are, or the data tenants that we are using in, right? See, there are a lot of combinations that I earlier mentioned. We have master slave, we have follower. There's a pattern, I think I might, the nomenclature would be wrong. It's a quad pattern that DynamoDB uses it. We can get into the internals offline, where a quad pattern is something which handles all these data inconsistencies in terms of in a multi-tenant kind of in a mechanism. Anything more to add?
No, I think this broadly covers. I think a follow-up question can be raised if you are still not clear on the chat. Okay, moving next. So microservices versus APIs. What is a microservice API? In which scenario does companies can prefer having a monolith architecture over microservice architecture? I think Asif is presently helping building one such kind of a product from scratch. Yeah. So I think he can handle this question, answering like where to use monolith and where not to use monolith.
Yeah, before I go here, I would like to answer in the previous question, right? I think Saga pattern is something that we can explore. and that is being taken by or looked at in industry wide. So let me come back to this question now. So yeah, what is a microservice API? In which scenarios does company prefer having a monolith architecture versus microservice architecture? So this is, I think, very applicable or very apt for an industry or a company or an organization which is just starting to build a product, right? Which is beginning to build a product. So it has certain ideas formed and it wants to build a product. It has got all the DDD principles in place. It has, the FRD and all the necessary diagrams, all the necessary documents written down, all the architecture mapped out, charted out. And this is when an organization should go with a monolith architecture. They should build it out very quickly and using the principles they have in mind, and then launch it, get feedback, and go for a microservice approach. Because what happens with that is the iteration time is reduced to a huge extent. So basically, you have a release happening very quickly, feedback gathered very quickly, and this can be used in your version 2, which has a very detailed microservice approach, built into it from day one, right? But if you look at a company like Netflix, right? So it has everything running as a monolith, and then it realizes that it's not able to scale up. It's not able to scale. It's not able to add features like AI based recommendations, AI based reviews. It's not able to collect. And for a company like that, at that point in time, when it has when it has created a huge monolith and it's not able to scale up, it's not able to add new features very easily. It wants to break it down, right? It wants to make things simpler in terms of scaling, in terms of providing new features. That is when it should go for a microservice architecture. A big organization, even a small organization, it has a monolith architecture in place, and now it wants to go for adding more features, having better security, having better scalability, data isolation, coupling, decoupling, whatever we've seen so far. Go with microservice architecture. So version 1, very quickly build out your monolith. Version 2, go for a microservice architecture. Yeah, this is the best approach in my opinion.
And we have, I think, last question from Sridhar. He's asking, during microservices IPC, how to handle multiple calls or multi-threaded calls from different microservices, keeping the performance and scalability of the system in mind, or is there better design for this problem? I think that handling multiple calls or this kind of load that you are worried about is pretty much easily handled. See, the microservice architecture is built in such a way where it's not very different from how Monolith works. Okay, they also receive external calls, and there also the traffic is high. And I think you can use. Let's say you have a lot of database query to make. Okay, you can use caching mechanism on your microservice to serve your request better, to not to reduce the delays in response. There are a lot of things that we can utilize, but be sure that, let's say, within a virtual private cloud or VPC, we have, let's say, 100 microservices. All of them would need to communicate, and for the fact of communication, there will be a slight addition in terms of the calls that they make and response that we receive, but there will be a reduction in the form of computing and providing you a response. Okay, so there is a trade-off in this scenario, and this you have to, I think, the design pattern remains same. You can utilize the microservice, but you need to do what I mentioned earlier, parallel run. Do a parallel run. Okay, if your monolithic architecture that you're migrating from provides, let's say, there you're getting response in 2 seconds, and in microservice you're getting in response in 5 seconds, then your microservice implementation is wrong. Okay, the variation should not be that big. Maybe 2 seconds, 2.5 seconds, understandable. Okay, you can add a lot of techniques to, you can refactor the code on microservice, you can add caching mechanism, you can add different functionalities to get the 2.5 or 3 to down to 1.8, 1.5 seconds in terms of response time. But if it is giving 5-second response time, then you have to come back to the board and see what went wrong in that microservice and why it is having that much of a response time. So it's always like when you are breaking out, always do parallel runs, always check and baseline your new development with the existing module that you have in place. Anything you have to add here? I think the comment, Asif, Divyang.
This is a very similar, a very important question though, very good question, Sridhar. So if you look at multiple calls happening, right, it is something that can be easily worked around using orchestration, something that I mentioned earlier in the previous question. So using an event-based reactive approach, this problem should be easy to solve. And as Shashank said, we have to look at performance and scalability when we're doing that. Yeah.
One more point I would like to add here, like when you're telling about inter-process calls, right? There are various types of inter-process calls that you handle also, right? What kind of calls that you have, because as I mentioned, like is it synchronous calls? Are they asynchronous calls? So based out of their nature, their specific strategy also should be adapted. Like you cannot go with let's say, because if I would say an HTTP call, a JSON based response calls are much more heavier in terms of data than a gRPC call, right? I would say it's a 30 to 40% of rate change that we can see. They're much faster in a binary format, right? They are different, like you can use for binary buffer protocols as well to do these intercommunications between the services. And when we talk in terms of threading, right, in terms of thread-based calls, it also depends upon the machines that we have without sufficing, because you cannot run 10 threads or many, like 100 or 200 million threads or whatever threads that are there on a single core machine. Right. It also depends upon the infrastructure to handle a specific load as well. And your these load balancers, your application load balancers, these are orchestration tools can help you out to solve your problems at the end of the day.
All right, guys, then I think we are done with the questions as well. If you have any further question, you guys can write us up and we would be happy to answer later.
Okay, well, that's all we have for you today. Thank you for joining Codvo for discussing microservices architecture migration. We appreciate you signing in and hoping we are able to deliver the microservices transition from Monolith in the best possible way in this session. If you have any further queries or would like to have any more information, please feel free to reach us. Till then, adios. We'll see you next time.
Thank you, everyone. Bye.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone.